Thank you everyone for watching this video. Today I'll be working on the shift register. On the last video I did work on the load comparison function. Let's begin by adding a normally open contact and yum8125 125. Okay, and we will move couple values to data register. Okay, let's move 1 2 3 4. Let's move make this double 1 2 3 4, and let's move that value to D0. Okay, and D0 and D1 will be D, not O, not O, D0. Okay, so basically this is a 32-bit value double. Okay, and we also want to move a word. Control C, Control V. Let's make this word. Okay, and let's move that to D35. Okay, and normally open contact I1. Okay, and we wanna use the shift register, right? So shift register is used to move the data bits from the right to left. Okay, so you will move 0 or 1 to the lower significant bit, and the most significant bit will be moved to carryover. Okay, that's what we are trying to achieve. So S1 is a 32-bit register. Okay, and S2 would be 0 or 1 that will be moved to the least significant bit of S1. Okay, NB is a number of data bits in a string. Okay, so basically data string. So if it is double, that would be 32. If it was word, that would be 16. Bits is a number of bit that you want to shift. Okay, already let's define this S1 as D0. Okay, and let's move 0 to the least significant bit of S1. Okay, and that would be 32 bits since it's double, and we are shifting 1 bit at a time. Already, and now I want to explain one more thing. You are moving 1 2 3 4 1 2 3 4 to D00, right? But what happens here, this D00 will be converted to different number because you are shifting the value to the left. Okay, let's simulate the program here. Initially it has 1 2 3 4 1 2 3 4, right? And what happens when the input is on? So this number changed to 2468 2468 because you have shifted 0 to the least significant bit of S1, and the most significant bit is moved to carryover. Okay, and I also want to show you what if you are moving 2 bits. Okay, would that make a difference? Of course, that made a difference. Here this D1 has not changed. Because of this shift, this D0 value had changed. Using 1 bit or 2 bit, the value got changed. Okay, that's how you do shift left or shift right. You could do anything. Let's try shift right here. What happens at that time? Okay, and you will see changes here again. The other thing I want to show you today is a calculator here. Oftentimes, as a programmer, here is a couple things you can use which makes life simpler. Let's say what would be the hex 1 2 3 4. I mean binary of 1 2 3 4 1 2 3 4. Okay, that so this would be 32-bit here. Okay, 00. 0001 0010. This is the value. Okay, so what? Okay, CE, and let's say we know that, so hex F F F F F F F F, that would be all ones, you know. So if you move 0 here, that will move this 1, the last bit of 1, the most significant bit, to carry over. That's how the shift left is compared. You do the same thing here. This, if you do the shift right, this 1 will be moved to right, not to the left, okay, at this time. And that's how the shift register is carried out already. And let's do a word shift now. Ready, here, word shift, we want to shift a word. Okay, here you want to move D35, oh, D35. How many of the register you want to move? Maybe you want to move 3, okay. So 35, 36 and 37 data register will be moved to D40, okay. So you will be moving the data to D40, D41 and D42. That's why you are moving a word, you are shifting a whole word, not just bits, okay. You are moving D35, D36 and D37, okay. This yes to says how many like data register value you want to move to destination register, okay. So this is how it works, okay. Alrighty, let's simulate this, and the 35 is moved to D40, but in this case we have been shifting word shift, and we did that to 3 different registers, 35, 36 and 37, moved to 40, 41 and 42. That's what we did. Alrighty, and let's add a line here. Okay, rotate left and rotate left of D35. Okay, preset value is 1 bit. Okay, let's close this. Okay, now let's simulate the program here. 2468, because as you know, this 1234 had changed to 2468, okay, and this word has been shifted, okay. Alrighty, this rotate left, okay. What if we do the rotate right? Alright, that would make a difference, of course, right? And let's use 1 bit now, and we can use 2 bit as well. 617, okay. And let's do this one more thing here. Let's do 2 bit, okay, and that will change that number. So you see. Alright, now I want to go over this function, okay. Let's do this function and see on the help screen what we are trying to achieve here. When the input is pressed, the value is 1, 32 or 62 bit, okay. In this case 16 bit, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, the least significant bit here, okay, and the most significant bit here before shifting, and you move 0 to least significant bit. So this 0 here on the least significant bit will be moved here, okay. You see that? So and this 1 here is moved to carry over. That's what we are trying to do. So this, once this number got changed, that number will be different in hexadecimal, okay. So that's the change we were seeing. Other thing I want to tell you is you can do 32 bits, 16 bit. We did 32 bits earlier, right? So but you can do bits to shift 2. So basically you are moving two bits, and this bit will be moved to carryover. Alrighty, and yes, too, you shifted 1 to least significant bit in this example. Let's see ROTR. So basically on the rotate right, you are moving this 0 to carryover, exactly opposite to the left shift, right? Rotate, and the rotate would be this 0 will be moved to most significant bit, and this 1 will move to the next place. Okay, that's how the shift register is done in Idec PLC. Thank you so much for your time. I hope you enjoyed these videos. If you do like the videos, please do subscribe my channel. I hope to see you on the next. Thank you, and you have a wonderful day.